Alright, this is tutorial 5 of linear programming tutorial. So we are still trying to solve the linear programming problem, the diet problem, and we are using the graphing method, which is actually the easiest method to use. So far so good, I hope you've been following. So today let's try to see what we can do. So in the previous tutorial, 4, we created these 4 graphs representing all the constraints. Well, before I continue, I'd like to remind you to subscribe by clicking on the subscribe button below so that you get notified when I make new lessons, and also you encourage me to make new lessons. Alright, so I've written all these, so the next step is to combine all 4 graphs into one. So to do that, you draw somewhat bigger coordinate, and then you put in the coordinates, you draw a bigger plane, put in the coordinates, so you have from the smallest to the biggest. So here you have 5, here you have 20, here you have 58.3, right? Good. So on the a-axis, you have 8.3, here you have 30, and here you have what? 175. So also we have this to be B and this to be A. So if I'm to draw the 3 lines, so let's see how it goes. So this one goes down from here to here, right? So the second one, 5 to 8.3, 20 to 30, right? 20 to 30, yeah, 20 to 30. Draw a straight line. Okay, let's leave it this way. So let's see what we can do with this. Okay, so now we have the equation that satisfies everything, or the graph that satisfies all the constraints should be up here, right? So that is why we can call here the feasible region. So this is called the feasible region. So technically we have solved this problem because we found out the solution to this problem. But we need to find the value of the cost function that will be minimal. All right, so let's remember our cost function. Let's go back a little so that we check the cost function, and the cost function says 8a plus 10b. So sorry, not here. So remember our cost function. Let me take my pen again. The cost function says f of a and b equal to 8a plus 10b. Remember, you can just pause this video and try to get your head around it. If it's still somehow challenging, you can leave me a comment to tell me what challenges you have. Alright, so if we look at this function, we want to find the minimum value of this function, right? And the minimum value of this function, whatever it is, has to be in this region. Yeah, it has to be in this region. The reason is because we are saying that these constraints applies, we found the feasibility region, so it has only to be in this region, right? So to be able to find the value, the minimum value, means that it has to be a line down in this line. Yes, it has to be in this line, because if it's above here, it's not minimum. If it's below, it doesn't satisfy the constraint, so it has to be in this line. So in this line we have 2 points. We have the first point is this, right? And the next point is this. So either of these 2 points has to be the minimum. So let's see. We have, the first point is this, which is 0 and 58.3, and we have the next point to be 175 and what? And 0. Fine. So the easiest thing to do is to calculate this function with these 2 values and check which value is a minimum, and then we take it as a minimum, right? So let's simplify. So function at this point at 0 and 8.3 will give us 8 times what? 8 times 0 plus 10 times 58.3. That will give us 583. And let's calculate this at the other point, which is 175, and 0 will give us equal to 8 times 175, right? 175, not 17, plus what? Plus 10 times 0. So that will give us 8 times 175 quickly. Let's try to use a calculator. Calc. 8 times 175. 8 times 175. So that gives us 1400. So obviously the minimum value occurs here, right? So solution is at this point at 0 and 58.3. So which is equal to, A is equal to what? A is equal to 0 and B is equal to 58.3. So we have actually solved this problem and got the minimum value. The minimum value occurs here, and the solution for the minimum value is A is equal to 0 and B is equal to 58.3. So let's go to interpret this diet problem. Let's go back to, let's see if we can go back a little. So for you to spend the minimum amount, because you are trying to minimize costs, so what it means, you need to use 8 of A, right, and B. So let's see. Let's go back and see what we can do. So A is apple. So to minimize cost, you need to eat 0 units of apple and 58.3 units of banana. So there's a little interpretation we have there. So I hope this has been clear to you. I hope it's been informative. The next problem we are going to solve is also linear programming problem, and this is going to be, let me see, it's going to be the blending model. That is what we are going to solve next, and as we solve it, we'll learn something new. I'd like to thank you for viewing. Remember to subscribe if you've not subscribed, and then we see you in tutorial 6.